we have 13 problems here in front of you, which pretty much summarize solving quadratic equations. So let's begin with this first one here. We notice that it is not set equal to 0, as all quadratic equations should be. So we begin by adding 10 to both sides. We get 2x squared plus 12x plus 10 equals 0. Now, since all three terms are even, I'm going to factor a 2 out, leaving me x squared plus 6x plus 5 equals 0. And what's inside the parentheses is still factorable. So x plus 1 times x plus 5 equals 0. And then when there's a 2 out front by itself, we ignore it. And so we just have x equals -1 and x equals -5 as our two solutions to this quadratic equation. Here we go to the second one. And we notice there's only two terms on this equation on the left-hand side. And so we resort to factoring. We notice that 8x can be factored out. We're left with x minus 1 equals the 0. And we'll then use the zero product rule, saying 8x equals 0 or x minus 1 equals 0. On the left we would be dividing by 8, and over here on the right we would be adding 1 to each side of those equations, and we get x equals 0 or 1 as the solutions to our equation there. Okay, third equation, again not set equal to 0. So the first thing we want to do is subtract 7 on each side of the equation, leaving us with x squared plus 4x minus 3 equals 0. Now we look at this and we say, okay, can it factor? 1 times 3 makes a 3, and 1 plus 3 makes 4, but when we try playing around with the signs are going to be all wrong. So the question now is, what method do we go with? Since there's an even number in the middle, I'm going to complete the square. I'm going to write x squared plus 4x, leave a blank, equals positive 3. There is no leading coefficient to divide off. The 4 will cut in half to a 2, and that will square to a 4. And adding 4 to the right, I'm going to get an equals 7 on the next line. But let's complete the square first. X plus 2, quantity squared, equals 7. Square rooting both sides gives us x plus 2 equals plus or minus root 7. And subtracting 7 on both sides, -2 plus or minus root 7. Now, if you insist, you could use the quadratic formula to solve that. And if you're going that route, let me make enough space here. I'm going to move that up a little. We're going to write b squared minus 4ac for starts. And our b is going to be 4. So 4 squared minus 4 times a, which is 1, times c, which is -3. Notice I'm going to the form of the equation that's set equal to 0 first. That gives us 16 plus 12, which is 28. Continuing on, we would have x equals -b plus or minus the square root of 28 all over 2a. Now 28 can be broken down into 4 times 7. So x equals -b, that becomes negative of 4, plus or minus 2 root 7, the 2 comes from the square root of the 4, all over 2a, that's 2 times 1, which is 2. I'm going to now factor a 2 out of the numerator, leaving me with -2 plus or minus root 7 all over the 2's, which cancel. And you can see we're going to have x equals, let me squeeze this in at the bottom here, -2 plus or minus root 7. Now I wanted to kind of show these two side by side to you so you could see how different they are by comparison size-wise. Notice complete the square is actually shorter and easier for this problem. It's not always that case, but it is for this problem. And that's because there was no leading coefficient and there was an even number 4 in front of the x, which was easy to cut in half and square.